Hi guys, Katya here, and today I'm gonna do a walkthrough of a programming exercise from the D.S Malik textbook, chapter 5, programming exercise number 6. This is a programming exercise, not the regular exercise, so please pay attention to that. All right, let's get to it. I got here the program exercises. What it says is write a program that prompts the user to input a positive integer. It should then output a message indicating whether the number is a prime number. And there's a note here that says an even number is prime if it is 2, an odd integer is prime if it is not divisible but by any odd integer less than or equal to the square root of the number. All right, so that can be a little bit confusing and tricky, so let's get to it. The first thing that I wanted to do is I wanted to include the IOStream library, of course, but also I wanted to include the CMath library, and this is because I'm going to be using the square root function in this program. All right, so the first thing that we want to do, we want to declare three variables. The first variable is num. This is what will accept the user's input, the number that we want to, the integer that we want to work with. Then I want to also declare a counter. So I'm going to call it I, and for now I'm going to set it up for 1. And another value that I want to declare is a Boolean value. I want to use a flag, and in a second I will show you how we're going to use this flag. And for now I want to set it to true. Remember that a Boolean value can either be a true or a false. All right, so the first thing that we want to do, of course, we want to get the input from the user. So we're going to say enter a positive integer. All right, I think I misspelled here. Oops. Okay, like so. And we're going to add a new line just so it would, for readability purposes. And we're going to read it into the variable, the assigned variable we have for it, which is num. All right, so now the first thing that we want to make sure is that the user actually gave us a positive integer. So as long as num is less than or equal to 0, we're gonna let the user know that the value is invalid and ask them to enter another value. So like this. Okay. Or we can say, oh, we just want to say that the value was invalid. The value entered is invalid. And then we ask the user to enter a positive integer. And once again, we're going to read it into the num variable. All right, so as long as the user keeps entering numbers that are less than or equal to 0, meaning invalid values, they will receive this message. Now, once the user enters a positive integer, which is any value that is larger than 0 and is not a float, then what will happen is that this loop, either it won't execute, or if the user the first time around, if they put in a number that is less than 0 but then corrected themselves and entered the correct value, it will exit the loop. All right, so if we get to this point, this stage, it means that we have a valid integer stored in the number. Now we're going to perform serious checks with that value that we received from the user. So the first thing that we want to check is if it's smaller than 2, meaning if it's 1. So we can either say num smaller than 2, or in other words, num equal to 1. Whatever it is that you choose is the same, because we already put this condition on any number that is less than or equal to 0. So if it's less than and equal to, if it's larger than 0 but smaller than 2, it must be 1. All right, so I hope that wasn't too many words for you guys. Basically, what you can say is number less than 2 or number equal to 1. For the purpose of this program, it means the same thing. So if it is smaller than 2, or in other words, equal to 1, then we're going to put the flag to true. I'm sorry, to false. All right? Else if number is equal to 2, so in this case, 2 is a prime number, so we're going to set the flag to true. So basically, flag false. If flag false, that means that it's a prime. And if flag is true, it means, I'm sorry, if flag is false, it means that it's not a prime. If flag is true, it means that the number is prime. But for now, we don't do anything with that. We're just performing checks. And if that condition is met, this is the value that we assign for flag. Then what we're going to do is we're going to use flag to determine whether the value that is entered is prime or not. Okay, the next check that we want to do is else if the number is actually larger than 2. This is for all the conditions. This is for all the cases when it's larger than 2. So if it's larger than 2, now what we're going to do, we're going to perform the following actions. So while flag is true, because if it's already changed to false, we already know that it's not prime, so we don't even need to get into this loop. But there's no way for it, up until this point, there's no way for it to be false because it's not smaller than 1. The condition wouldn't have met. I hope you guys follow. If you have any comments, please link it down below. Please put it down below. So while flag is true, and we don't want an assignment, we want equality. So we're going to use equal. So while flag is equal to true, and while I, remember it's our counter. Oh, I didn't want the $sign. I wanted the and. My apologies. So I, which is, remember, our counter currently set to 1, is smaller or equal, because that's what the assignment told us, square root. This is the square root function, and we're going to use the value of num in it. All right, so while those two conditions are met, we're going to perform the following check. If the number module counter is not divisible by the counter, then we're going to keep flag at true. However, if the number module the counter is divisible, then we're going to put the flag at false. Awesome. So this is the checks that we needed to perform. Now let's output the results. So after performing those checks, right now we have a number and we have a flag. With that, we have the flag set to the value based on the checks we performed to the value of number. So the first thing that we want to do, we're going to use another if statement. So in this case, if flag equals to true, then we're gonna output the number that was entered is prime. Awesome. And for readability, I want to add a new line here. Now, else, I'm going to use else if, and I'm going to say flag equals to false, equals to false. Then I'm going to use the same statement, but I'm going to say that it's not prime. All right, so that's it from the program. Now let's perform a check. We're going to run the program and debug, make sure that there's no errors. Let's see here. And if they do, of course, we can always correct them. Okay, here it is. It says that I have a build error. Let's double check. All right, so we have an error on line 13. Let's go here. Um, oh, okay. It's actually not that, not STT. STD. All right, so let's run it again. Just a small typo we have here. Okay, so let's try to input a positive integer. Let's say that I'm gonna input -1, which is clearly not a positive integer. But let's say, see what happens. All right, the value you entered is invalid. Enter a positive integer. Perfect, it works. Now let's try to enter number 1. So it says the number that was entered is not prime, which is correct because 1 is not a prime. All right, let's try to run it again. This time, let's enter a number that I know in advance is a prime, just from previous knowledge. Let's say 97. Let's check. 97 indeed is a prime. Let's check if the program can recognize this. All right, the number is entered is not a prime. So we have, and clearly we have an error here because it does not recognize the prime. So let's see. Okay. All right, I know where the issue is. The issue is because we forgot to add the counter. Remember, since I didn't edit the counter here, what happens is, let's say the number is 97. So it meets the condition on 24, and it says, all right, the number is larger than 2. Great. Flag it's still true, and I, which is the counter, which for now is set to 0, is smaller or equal to the square root of the number. That condition is met also. But since I didn't have the counter, what happens is 97 is module 1, and it will always be go to false. But remember, we don't want to check the 1. We want to check any integer that it's larger than 1. So to fix this bug, the small bug that we have there in the logic of the program, all we need to do is increment the counter. And now it should work. Let's see. So we're gonna write the program. We're gonna run the program, and we're gonna enter the integer 97, positive integer 97. Okay, let's see. All right, the number that was entered is prime. Awesome, that works. And just to make sure, let's try one more number. Let's try a number that is not prime. How about 100? 100 is not a prime because it's divisible by 100, 1, 10, 25, 4, 5, 20, and so on. So it is not a prime. So let's check and see if the program can help us and output the correct statement. All right, the number that was entered is not a prime. All right, great. It looks like the logic works and the syntax is correct. So this is my program here for this exercise, exercise 6 from chapter 5 of the D.S Malik textbook. All right, guys, if you have a different way to solve this programming exercise, or if you have any comments or any questions, put them down below. I do my best to reply, and also take into consideration any requests for walkthroughs that you have. Hopefully this video helped you and anyone else that you know. Put a like and share to it, and I hope you enjoyed it. Have a good day. Bye-bye.